So tonight's lecture is on box gutter design, and it touches a little on flashings, etc. as well. At times it is a little bit, I guess, there's a bit of a crossover, a bit of a grey area between some of your flashings, what is classified as a flashing, what is classified as a box gutter. Typically, when you're dealing with parapet walls, you've got a roof sloping down to a parapet wall, and then you have some flashing that ends up being a pan that carries water to somewhere else. Essentially, you've created a box gutter. But, however, in residential situations, these are the typical type of box gutters you'll be dealing with. So, has everybody seen a box gutter before? Or yeah, they're very common. They do get poo-pooed a bit, but I think the main issue with box gutters is that temptation to under-design them, and if you give in to that temptation to under-design them, you open yourself up to areas in which they can fail. I'll just do a quick quiz. Can anybody think of things that would block a box gutter? Yeah? Leaves? Dirt, yeah. You need a fair dirt.
Branches from trees.
Yeah, branches from trees. So in really stormy situations, you get large limbs, and that's exactly when you don't want box gutter to fill up.
Birds.
Birds, yeah. Birds, nests,
Body.
Yes, definitely.
Balls.
What's that?
Balls.
Balls?
You get to kick them on the roof.
Yes, yep. And I might add to that balloons.
They're pop.
They take a while. Some of them deflate.
Oh, yes.
And thinking about those, anything else? Is it?
So you make this sound
Rubbish bag.
Yes, plastic bags. Yeah. Because you quite often get plastic bags picked up by whirlywinds and then dropped on roofs. The plastic bags. Hail is a really big one. So when you get a hailstorm, and you get all this hail that sort of goes down into the box gutter and then just ends up banking up at the low end, and then you get a lot of rain, that can be a real issue. But yeah, that's the main ones. Leaves, plastic bags, hail, branches.
You can some guards that one.
Yes, certainly. So you can put a leaf guard, and some poorly installed leaf guards can be more hassle than they're worth. So you need to have a continuous guard the whole length, because if you've got joined guards, they can just fall in and then end up causing you more hassle than they're worth. But you'd also want that guard to be able to be removed as well for cleaning, because you still get dirt and things like that through a guard as well. Yeah, in fact, yes, I lived in a house with a box gutter, and that box gutter was getting blocked or impeded by the guarding that was in the box gutter as well. So that's another one that can cause issues. So these are effectively part of roof construction. Correct design and installation are extremely important, as consequences of overflow or leakage are serious. So, because typically you're dealing with an internal space underneath that box gutter. So being part of the roof, they must also be insulated to comply with thermal requirements with respect to excess heat loss, thermal bridging, the risk of condensation. So for all your roofing insulation, you have to carry that insulation underneath the box gutter as well. Have to be wide enough and sufficiently strong to allow foot traffic during installation and maintenance, and comply with health and safety regulations. So the box gutters need to be supported in their base. in the pan underneath. We'll see that.
So our box cutter is against where our old cutter used to be, well, where the cutter of a house is.
Mm-hmm.
So then it should have to be insulated because there wasn't anything there before. So we got our normal cutter and then the box cutter next to it in front of it.
Do you want to draw the detail?
Cool. maybe I'm wrong here, but I don't know. So we've got our house is here with the usual gutter, however that was.
Yeah.
And
so
then
it's
we
an
got
eaves gutter.
And then we got a veranda here.
Right. Okay. Yeah.
So they put I don't know if it's lower or the same height. So sorry for that, but
Right.
so the box gutter is there.
Oh, right.
So they didn't remove the gutter, it's still there.
So you've got
gutters now.
Yeah.
So I don't know if it's the same height or not, but why would this have to be insulated?
Oh no, that doesn't. So in that scenario, a box gutter certainly doesn't need to be insulated. But that is. I didn't think of that scenario because that is quite a rare scenario. So you would have had that would have happened because the fascia height. So this is a veranda that's been put on, or veranda pergola, flat, the fascia height of your veranda there would be lower than your other gutter. That's the only reason you would do that.
Yeah.
I
think it's more so I didn't have to remove the old gutter.
Right.
Because, well, why would you destroy something that's working all right? I think that's what more.
Yes. Yeah. Or and this is something we'll cover later on. Also with the cross-sectional area of your gutter, so what sort of space there is in there, how much water it can carry at any given point in time. We have to, we can use online gutter calculators now, which is so much easier, which is much better than, when I studied this course and we had to do it manually through the code. But you have to work out what your roof catchment area is and how much rain is going to happen in a large rain event, and ensure that there's enough space in this gutter here to take all that. Now, as soon as you go adding another roof, you're adding a whole lot more catchment area to that gutter. One way you could help take the load off of this gutter is have more downpipes. So we have the plan view of our house here like this.
Yeah.
Got our gutter running all the way along there. Now, initially we may have had a downpipe there and a downpipe there. We add our veranda on here, which also gives that a lot more roof area. We may be able to get away with putting a downpipe there and keeping that same gutter. But if we've got a window here, a door, or something like that, for some reason we can't get a downpipe in a decent scenario, we might go for something like that. Or we can actually change that gutter and put in a larger gutter with a larger cross-sectional area. That's going to be possible if it's a gable-ended roof. If it's a hip-ended roof with a gutter that extends all the way around, it's probably not going to be an option, because if we're joining our gutters to existing gutters, we've got to want exactly the same cross-sectional area of our gutters all the way around all the way around the house. Otherwise, we just get some really funky details in the gutters there.
I guess that one is also avoided with the way it is at my place, because that box gutter is only doing one half of the veranda and the other gutter is doing the other half of the veranda. It doesn't have to keep in mind the rest of the roof. So that would have saved some calculations.
Possibly, yes. Yeah. So I guess so there are several scenarios, I guess, which would lead to that sort of detail, but that is a very rare detail. It's not something that is seen a lot. Typically you are able to get away with using your existing gutter there. And yeah, but it's quite a large veranda then, I guess. Yeah. What's
What's large?
How long is a piece of string?
I know.
Yeah.
I think it's 12 by 3 or something.
12 by 3. Right.
Question.
Yeah.
Who should design the park scatter product? Is our responsibility or duty?
Yes, it really should be the designer's responsibility because it impact. There is so much. How do I say it? When you're designing the building, if you're designing in a box gutter, you want to know whether that box gutter can fit, basically, and you don't want to go tell somebody else, can you design this box gutter for me? And they design a box gutter and it doesn't fit within what you're designing. So because it impacts so much on your work, it's much better if you can do that box gutter design yourself. And as I'll show you later on, it has been made really simple with online calculators for designing box gutter. Has anybody have you ever seen the box gutter calculator through the Australian standard?
No.
But yeah, if you're using it, it's very complex in regards to, we have to learn a little bit of it still to use the online calculators. But all we have to know about is our local rainfall intensity. So Adelaide, I think it's between 180 and 200. It's about probably it's 200. But we'll have a look at that later on. But yeah, designing box gutters with an online calculator is very easy. So box gutters are located within building. Gutters adjacent to a wall or parapet should be designed as box gutters, or where you got another roof that's been added onto yours. So what we're talking about, box gutters adjacent to a wall or this is where we have a scenario like, let's say this is our street here, our footpath here, like that, and then we have our large wall, our parapet, like that, and our roof heads down to our parapet. Because, rather than from the street having the view of the roof, we like to create that square facade front. This gutter behind the parapet needs to be designed as a box gutter. So you just use a box gutter calculator for doing that and the considerations for it. So the main principle in the design of box gutters is to avoid the potential for blockages which would prevent free runoff of roof water and possibly cause water to enter the building. So you want that water to be able to get out of that box gutter as easily as possible. And something that's used a lot on hay sheds, because with hay sheds, with your machinery and so on moving hay around, you get hay up in the air and you get a decent amount of hay, small bits of hay on the roof. Thinking about box gutter drainage in those scenarios is important for the blockage of them. So a lot of those have open-ended box gutters, so that the end is open, and then they have a rain head further down with a sloping mesh top. So the water can just flow straight out of the box gutter, be caught by the large rain head with the mesh top, and all the loose bits of hay and everything can just go away. They can sit on top of that mesh top and fly away. And personally, I don't think they're that unattractive. And I think you can use the same sort of scenario on a residential building as well to good effect. I don't mind that.
Do they also use that to keep, when you're connected to a rainwater tank, to keep the dirt out of the rainwater tank? Is it the same thing?
I have seen little leaf filter things like that, in some residential situations. But I think maybe what's used to keep rainwater clean is what's called a first flush system.
Yeah, I know that one too.
Yeah, but that is different than what you're talking about. Yeah. So yes, but there are those little sloping collectors with
So same principle, different size.
Yes, essentially yes, same principle, different size. Yeah,
Right.
yeah. Doing. So it's filtering out leaves.
Yeah, it's always placed at the right end of the pipe or something that goes into the tank.
Yeah. I'm trying to think of where I've seen. Well, where have you seen them used?
I haven't seen them used. I was looking to look up a rainwater tank. And
Yeah.
I came across that.
Yeah.
So it's very, you know how you've got the pipe on the side of the wall. Instead of it being connected, instead of being one pipe, it sort of stops.
Okay.
And underneath is a box with just a mesh around it. So the water just falls into that box. But because of the mesh, the leaves will stay behind the mesh. Because the mesh is not horizontal but on an angle, when it dries off, the leaves will just slide off.
Okay.
Instead of going in
Into the
the
tank.
pipe. Yeah.
So that's our building wall there. And let's say, just for ease of drawing, this one doesn't have any eaves. So we have our downpipe coming here, like this, off there, and then Armin, you're saying that the box is located on the wall. So we
So
we
the
chop off.
pipe stops there.
Yeah, pipe stops here, and we have a sloped mesh top
Yeah.
to our box. That, and then our downpipe continues from there.
Okay.
And so water comes out of here, and this is mesh here. So all the leaves and things go down there, and they sit on there, and the leaves go this way,
Yeah.
and the water goes in here.
Okay.
Because block the mesh. The leaves maybe block the mesh.
Yeah, but when it dries up,
We try
just
the
slide
flash
off.
off. Okay.
Yeah, it depends how many leaves, these are I can't remember where I've seen them and in what application I've seen them. I haven't seen any mounted on the side of,
Yeah, I
of
just saw
houses.
them when I was googling.
Yeah, no, I've seen them in real life, and I'm trying to picture where and in what application I've seen them. I can't think of it right now. But they're fairly steep mesh top, so it's probably somewhere between 30 and 45 degrees steepness.
And
but I think
every brand will have different ways.
yes, yeah. But I think that is an important consideration to think about leaves getting stuck on there and then the splash, which will happen. Because then you end up getting a whole lot of splashing on the wall, which is probably not a good idea, and then also water down here, which is not a good idea as well. The system I was suggesting is that, well, where we have our box gutter coming out there like that, and you have your but much larger rain head here like that with your mesh top. Although that is still a consideration, that thought of splashing, etc. So possibly you want some sides on there, but the ones I see on hay sheds don't have sides.
Maybe it's less important with hay sheds.
What's that?
Maybe it's not so important with hay sheds.
Well, it's not so important with hay sheds, no. Yeah, you don't want lots of water
No.
splashing about, but yes, typically, there's.
But one thing is to
Great
consider
tolerance.
is the size of the pipe coming down and the size of the box. Depends on how big the box will be. I've not seen one, but for the size of the pipe to sit on the box, so any leaf that can come out of that box, I don't think it will be wide enough to stop water or splashing. If that idea is created, I think they should consider that before creating the box.
Yeah.
Yeah, that's what I think. I don't know.
Yeah, I think so eucalyptus leaves, etc. They're definitely small enough to pass through downpipes, etc. But they can be fairly rich, and they can get stuck in things, and then you can get water hitting those. Yeah, something to think about and explore.
How important really is it that if it's splashing, because it's raining anyway, so those areas are going to get wet anyway?
Yes, they are, but then you have an intensity of water happening there. So this is true. Yes, you do. Yeah, you do have rain happening and get wet there anyhow, but it's about how much it gets wet. And if you've got continual splashing in one area as opposed to another, you might. But does everybody know what a first flush system is? Should I draw one of those? While we're on down pipes and things like that. So we've got our house, the roof like that, and gutter here like that, and there are several ways of doing it. I'll draw it up just in principle. This is not a very attractive way of building one, but we have our down pipe coming down here like this, but it doesn't go all the way, and instead we tee off, say there, for example, and then that goes down. So you wouldn't do it this way. You do it both flush with the wall. This is a very unattractive way to do it, but it shows it diagrammatically what's happening. We have a screw cap on the end, just one of your UPVC screw caps that you use for an inspection point or anything like that. And then you have a little bit of a lip in here, and you have a ball in there that will float like a styrofoam ball or a solid, like a hollow plastic ball, and then you have a little, we have a little hole there, and it's best practice to run a pipe away from that tiny little hole at the base, and then your down pipe continues up there. So when you get water coming in here, the water initially goes down there. So that's your first flush. So when it first starts to rain, it picks up all the dirt and grit and so on out of your gutters, and that goes into this pipe here. That ball floats up to the top when it gets full, and all the water then flows down there. So the first bit of water to come off your roof and stuff with the bird poo and things like that goes into this pipe here, and then through the small hole at the base, it drains out slowly. So over the next couple of hours, that drains out and the ball goes back down again. And that's, so if you're going to do rainwater harvesting, I think that's a good system to add on, like a rainwater harvesting for drinking. So avoid blockages, etc. So to avoid potential blockages, box gutters must be straight. So not have any bends. So where you've got bends, you've got the possibility for obstruction. But where you've got bends, you've also got joints, etc., which open things up to rust, and you want to minimise potential for rust as well. Have a constant base width and vertical sides. So at some point through your gutter's cross section, you still have to have vertical sides. Now, one way of doing a box gutter can be like this. So, and this is, for example, our rafters. So we would do that in a scenario where we want to keep our purlin height to a minimum, but still accommodate a large box gutter. What we cannot do is a box gutter like that. So we have to have verticals at both sides. Another thing we cannot do is do a box gutter like that. So that's what's called a V gutter. The issue with a V gutter is it's all in this little bit here. When you get steel, it's coated with zinc aluminum or galv or colour bond over zinc aluminum, whatever. When you bend it, you compromise the surface of that zinc aluminum or the galvanizing to a very small, sometimes it's very little compromising, but you compromise it. And where is dirt and dust and grit and so on going to accumulate? It's going to sit here, that little bit there. And so when you get dirt and dust and so on accumulating, you get moisture sitting there as well. So you add those things together with a compromised surface coating, and this section rusts out very quickly. And so that's why you need to have a portion of flat pan to your box gutter. But yeah, that sort of thing can be done if you don't have very deep purlins. Box gutters have to have a longitudinal slope between 1:40 and 1:200. So your minimum slope is 1:200. Changes in slope are not permitted. So you don't start at 1:200 and go, oh, I've got a bit more space. Yeah, okay, we can bring it down to 1:80 or something like that. Have to keep constant slope from one end to the other. Another important consideration is if you're building on highly reactive soils and you're dealing with very little slope in gutter, I guess it's dangerous territory is what I'm saying, because with highly reactive soils you could get one end of the building lifting up 100 millimeters more than the other, and 100 millimeters, that's what is that? I think that's 1 in 200 slope over 50 meters. So for anything less than 50 meters, 1 is 200 slope, you can end up reversing the slope of your box gutter from one end to the other, if that makes any sense. So particularly when you're dealing with really long runs and you're building on reactive sites, it's best to be conservative with your slopes. Discharge directly into a rain head or sump at the downstream end without change of direction. So mid-span in box gutters, you can have outlets going into rain heads, but at the end of the box gutter, it has to go straight out the end. You can't have the end of the box gutter and then off into a rain head. Does that make sense? No? I'll draw that diagrammatically. So let's say we have a big, long, fairly boring rectangular building with a box gutter all the way along one side. We've got a roof slope happening this direction like this, down to our box gutter. Our box gutter, we're limited with the size of that, so we think, okay, we've got to put a rain head in here, like that, with a downpipe there, so we can have an inlet into that. That's fine. One here, like that. But when we get to our end of the box gutter, so the slope of our box gutter is heading this way. Yeah. That's our slope. We get to the end. We can't go putting in a rain head there. We instead have to put it here, because what we don't want. So we can have these, these ones taking whatever discharge, helping out as it goes along. We don't want water cruising down here, picking up speed, and then hitting this bit and having to go that way. We want it to go straight out the end. The minimum width of box gutters for commercial or industrial construction is 300 millimetres. For residential construction, a minimum width of box gutter is 200 millimetres is permitted. However, such gutters are more prone to blockages and should be subject to more frequent inspection and maintenance. Yeah, so 200 millimetres, you know, that is sort of getting small ball size. Industry guides to good practice recommend minimum base widths of 500 millimetres for valleys. So that's where we've got two grooves heading in to each other, and that makes it very easy to clean out. But this is in an industrial scenario. So industry guides to good practice recommend 300 millimetres for parapet and boundary wall gutters. So here is that could be either. It could be a parapet or a boundary wall gutter. And so here's a typical detail through a box gutter in a parapet situation. And yeah, so I mentioned I'm just pulling figures out of the air. I haven't calculated it on my phone or so. But let's say that a 1 in 200 slope over 50 metres is actually 100 millimetres. When you've got details like this, you know, the draftsperson can draw that up and go, oh yeah, look, our purlins are, 250 high. We've got it on a cleat, picking it up 50 millimetres above that. Yes, we've got space for a 300 millimetre box gutter, but the thing is, you have to have space for a 300 millimetre box gutter, plus your support, plus that 100 millimetres that's going to fall from one end to the other, or 50 millimetres if you're dealing with a shorter stretch. And so when you add that 300 millimetres to your 35 millimetres for your angle, your 14 millimetres or so for your sheeting, so you're at about 350 there, and then let's say we have to have 80 millimetres fall from one end to the other. All of a sudden you're what are we at? 430 millimetres we need from here to there. So, and that's why it's good for the designer to be designing a box cutter as well. For them to go, oh, crikey, we don't actually have that, that 430. Let's go for a wider box cutter that's a little bit shallower, for example. So industry guides, good practice recommend. In general, the shape of these gutters will be dictated by roof slope, design flow, rate, and the distance between downpipes. This one's called standard box gutter for a very good reason. You rarely see any variation from that. If you do see variation, it's probably going to be this one. So that's where you have a box gutter in a valley scenario, and you have those upturns going onto purlins. You'll also see this one, an angled box gutter in a scenario like I drew previously.
But with that one, you've got a corner again. You don't have the horizontal.
Which?
Like where the two points at.
Yeah, that's true actually. Yeah, and I don't know what the. Yeah, that's a really good point. Yeah. What the one you will see is with an angle and then a flat, and then So Stratco standard box gutter profiles. So there are now I can't remember what the definition of a V gutter is, where you have, as I drew up there, where you have that angle, but there's a certain angle. Like once you get over a certain angle, then it is a V gutter and you're not allowed to do it anymore. I guess, Stratco would know much more about gutters than I do. And yeah, look, and I assume that this is up-to-date information. So possibly you can do that because this angle is sufficient angle. No, but that's very well picked up upon. I don't actually know the answer to that.
I guess because it's close to the steepness of the slope is not that much. That's why. Maybe that should be like 270 or say 260. The angle would have been like very steep. So it would be hard. It's very easy for that to go in there.
Yeah.
Than that one there. That should be less than 5 degrees.
Yeah. That I don't have the answer. That I don't have the answer to. Yeah, but look, reading through the Australian standard though, it does say that you need to have a flat base. And that to a portion of that flat base has to be consistent. I do wonder why Stratco do have that as an option, from what I understand of the Australian standard. Yeah, we can read through that. Industry guides and good practice also recommend additional freeboard over the maximum water level to allow for splashing in waves up to 75 millimetres. So freeboard means an area of height beyond what is calculated for our water height. So I won't draw on that. I'll draw this one here. That's our box gutter, our water height. That's what's called freeboard. So, so 75 millimetres. However, when we go designing box gutters, typically we don't go, okay, this is the amount of cross-sectional area which is going to be filled with water. We allow the Australian standard to have specified all of that, and then we just go through the calculator either on the Australian standard or an online calculator to do that. And it tells us the height of the box gutter.
So is that designed so no water can go through? Because you don't want water underneath the roof. What if
the flash ones.
Yeah, so what if the water level goes higher? Can it go underneath those green lines? So sort of in between?
The flashes.
Because water goes everywhere. Can it go sneakily go through here and get to the roof
certainly.
You don't want that.
No, you don't want that. Typically when we draw details and construction details for that scenario. So we've got our box cutter here like that, and it's been drawn with a gap, and with a with a little gap in there. When we draw, can that be seen from back there? But when we draw something like that, we draw that so it can actually be seen. What we are specifying in real life is that piece of metal pushes against that bit. So we would want that to be installed so that the tension of that metal is pushing against this side. Now that's not going to provide us a seal by any reliable standard, but what it does, it still impedes water, and if you get waves and splashing, etc., that effectively what you're doing is you're increasing the height of your gutter to the underside of your roof rather than to there for waves and splashing and so on. So, but it's not going to be a water seal, and when you get water up to this height like that, you'll get water going inside. So your box gutter, and using the box gutter calculator, is going to design you a box gutter where the water level is designed to sit at that sort of height as its maximum. So, but these bits of flashing here are for waves and so on in a box gutter. because we've got a really bad storm and we've got wind howling down through there. It's whipping, so that water is coming on the roof and it's sort of whipping it up and it's splashing, etc. These little bits here just ensure that all that water splashing is on isn't just going splashing and going straight over the edge there inside there. It's hitting this and dropping back down.
If you've got a plastic bag stuck in your downpipe,
Yeah.
you're still going to get water in your roof.
Yeah. And if you've got a plastic bag stuck in your downpipe, you're going to get water in your roof at some point in time. You know, it might be that you get water right up to there, and all of that water goes into your roof. Yeah.
But is that 75 millimeter 3 inch for the maximum? Is that for the freeboard?
Well so that's suggested.
Why is it it's maximum?
The minimum.
What's
Should
that?
be minimum, isn't it? We're getting it's not going more than 3 inches.
Oh, well, so to addition for over the maximum.
Up to 75 minutes maximum. Isn't
Yeah.
it?
So maximum. So the calculated maximum water level. So let's say we've gone through the process of calculating the maximum water level, and we arrive at 110 millimeters, for example, as our maximum water level. It's best practice to then add 75 millimeters more onto that 110 millimeters to get to 185 millimeters depth.
That says it's a maximum. So we can't go furthermore. 3 inches. That means we can't go furthermore, isn't it?
Yes.
I thought it should be. It's a minimum.
No, so so this is expressed as a minimum. So waves up to so what it's saying is we can get waves up to 75 millimeters. So that has to be catered for. So yeah. No, I see what you mean, and I see how that sentence can be interpreted in several different ways.
I thought that 75 millimeters is for the height of that freeboard.
Yes.
Is that?
Yes.
No,
Yes. So
this is for the height of the waves.
yes. So
You were saying.
yeah. So the what is
Because it's confused.
yeah.
It initially said it's just for the freeboard, the 75 millimeters.
Yes. Yeah. Because you can get
75, we should have a minimum 75 millimeters.
yes.
Minimum.
Yeah.
Of
Because
maximum of water level.
because the worst waves you can expect in a box gutter are 75 millimeters. You're not. Yeah. It's saying like, you can expect waves at up to 75 millimeters. So you have to cater for that.
Yeah, that's right.
So we've calculated a maximum water level, and then we chuck 75 millimeters on top of that because in worst case scenario we can get waves up to that height. Yeah. But yes, I see how that statement can be interpreted in.
So it doesn't
many
mean that
ways.
we can't go any lower than it can go lower than that.
Oh, you can. You can. So these are just industry guides to good practice.
Okay.
And so where you have, and what I'm saying in regards to box gutters, where you've got plenty of clearance and depth and the ability to have a good slope on a box gutter, do it. Use it all. It's much better to way over design a box gutter than to under design it or to take it right to the end.
You can use a pumping system, something like this one.
A pumping
System.
Yeah, in what regard?
The
Flush them away.
worst scenario. If you have a lot of rain, and we have a limitation for design and
That is an interesting idea, but I would not want to put my name to that. What I have seen a lot in stormwater design, and it's allowed, sumps. So I've seen it in ground. So you've got sumps in the ground, and then like where you've got I'm not sure if I drew this up, previously in the class, but we've got a street level up there, land slopes away, we've built our house with straight walls down here like that. And our gutters, the height of our gutters are below the height of the street. Out back here we've got other houses and things like that. We can't send our stormwater that way. It has to go this way. One scenario is that we have sumps in the ground with a submersible pump, and it pumps the water up. The problem with those pumps is they fail one day at some point in time, and they don't tell you when they're about to fail. Yeah, when there's a storm and you have a blackout, that's a really good one. But they also have a limited lifespan, and they just and they also get dirt and things like that in there as well. But at some point in time they fail. And I really don't like those scenarios very much. Personally, what I prefer is, say, a 2,000 litre tank with a submersible pump in there, and then your downpipes going into there. Then at least you've got some warning. So you go, oh, look, yeah, the tank's full of water. My pump has stopped working. At least you've got a chance to look at that before all your water goes to the neighbours. But specifying that sort of thing in a roof, where where you had a pump, a submersible pump in the roof, and the results of that failing are you flood the building. It's possible, but it's dangerous territory.
Yeah, but in this scenario, if you're pumping how would you want to be pumping the water up the hill of the land or something?
Yeah, with a little submersible pump. So it's a pump. It's a pump that has a float on it. So it's a pump that can sit underwater, and then when the water goes there, the float arm lifts up like this, and it turns it on, and it pumps the water out. Yeah. And when it's pumped the water out, the float goes down, and the pump turns off again. Yeah.
Just like the water system in the toilets.
Yeah, like that in reverse. Yeah, exactly. Yeah. And those pumps are really cheap. They're quite cheap to buy. But they fail at some point in time, and I've seen a few failures. So the method for design of a box cut is as follows: determine the catchment area draining to each downpipe. Determine the design 5-minute duration with a 100-year interval, average occurrence interval, rainfall intensity. So it sounds very technical, but that's all supplied for you in the Australian standard. Select the width and slope of the box gutter to suit the building layout. And there might be a bit of going back to this point. So you work through this and go, oh, that's not really working, let's go back to this point, determine catchment area drainage to each downpipe. So the method for design of a box gutter continued. Determine a minimum depth of box gutter. This minimum depth must be used to the full length of the box gutter, so as explained earlier. The box gutters shall discharge via a rain head or sump to a downpipe. The required size of downpipe from a box gutter is determined from design charts. So ASNZS, NZS 3500.3, 0.2, 1998. So this standard, AS 3500, is actually a very big standard. So AS 3500 is for plumbing. Covered in plumbing is also roof plumbing and roof drainage and storm water. So don't be confused by if you search for AS 3500 and you bring that up, you won't find anything in there about box gutters. You have to get AS 3500.3. The sizing principles to limit the maximum capacity of the downpipe in order to prevent slugs or unstable flow. So So have you guys covered box cutters in compliance or so?
There was only one question about it.
Right. Yeah. Yeah. There seemed to be a knowing nod in regards to that one. So the graph does not permit very deep or very shallow rain heads. So yeah, and I said, I guess really, well, actually I won't take you through all of that because we have online calculators. Some of this stuff is becoming superfluous. However, I will say that when you do it through the code or do it online, it'll give you a size of rain head. It'll say 275 millimeters deep, 150 millimeters wide by 300 or so. Typically, you'll be given a very small rain head anyhow. Then you go to buy one, and they're really quite large. So generally there's not a great. So you calculate the rain head size for reassurance, but typically all the rain heads you buy from a sheet metal manufacturer are fairly large anyhow because they're used as an architectural feature and they tend to be oversized anyhow. So it's rare that you'll be struggling for an adequate size of rain head. The minimum depth of water in rain head is limited to about half of the diameter of the downpipe. Above this depth, orifice flow conditions apply. So that's spillage outside. Standard rain head includes an overflow to safely discharge flow from the box gutter, even if the downpipe is blocked. So we get our tennis ball in there, water can spill out there. This may be an important one. The design flow of a rain head shall not exceed 16 litres per second. Now you need quite a large catchment area to get that 16 litres per second, but because think about it, it's a lot of water and a very big box cutter to do that. But that may be the case in industrial scenarios, like where you've got really big sheds. Then you can no longer use the code for sizing one up. You have to have an engineer specify what size. So ASN 500 states overflow devices or measures shall be installed where overtopping of the roof drainage system could cause significant monetary loss, property damage, or personal injury. So that's basically in all scenarios. Maybe not for a hay shed or something. You're maybe not going to have significant monetary loss, but there are very few scenarios when you're talking about box gutters where system failure would not be expensive. So these are the charts for determining size of the box gutter from the Australian. What's that?
I do not understand that chart.
Oh yeah, they're horrible. I've used it once since I studied. When did I study this? Back in was it 2007? So 10 years ago. I've used it once since that. And now they're. I'll show you later. There's an online calculator that does all this anyhow. So rather than work through minimum depth, box gutter, okay, we're here, then rainfall intensity, design flow, and then. This is just a reminder in regards to flashings. So it says work through the Stratman PDF on Moodle for typical flashing details. So when it says work through there, just have a look through. So I'll show that link actually after the lecture. It's pretty good link to show potential flashings and to get you to think about flashings in walls and roofs, etc., and to think about what details are possible. So detail typical box gutter to rain head at side of box gutter. So this is not a rain head at the end. This is one of the intermediate rain heads. And so what's also not being shown in here is our pop with the downpipe going into there, how that's discharging. But oh, actually no, we've got a dashed line here. Okay, that's how it's discharging, possibly. Anyhow, I don't see how that's linking up with this, but yeah, okay. But let's disregard that. The other details are fantastic. So what we have here is we have a truss with the bottom cord continuing through. So the extent of that would be, sloping up continuously at that probably 5-degree pitch or something like that. We have our metal decking that goes underneath the box gutter to support the box gutter. It's a bit clouded by this joint in the screen, but we have our box gutter going up like that, and we have a flashing overlapping our box gutter being carried up here, and then another flashing overlapping that one and going over top of the parapet. We have angled packing in here to create a slope back towards the box gutter. It's always important to create a slope back towards the box gutter, not toward the outside of the building. You get ugly staining and so on if that happens. We have flashing here to accommodate for any splashing and things like that, and also for as our box gutter further upstream gets higher and higher and higher, that flashing becomes less and less and less, and our box gutter sits up there, so that flashing can bend up to accommodate our box gutter. So it creates a continuous flashing there to stop water splashing there as our box gutter gets lower and lower and lower. We have our insulation shown in there, so the insulation carried in under the box gutter. And I think that's the extent of the important aspects of that detail. But yeah, it's very, very typical detail. Any questions in regards to that?
Anti-splash flashing.
Yes. So that's this little flashing here.
Yeah.
Goes.
Like you're explaining there on the gutter.
Yeah.
And said it should be like always slope at the bottom of the pole lines there. But that one is sloping right from the top of the pole lines.
Yeah.
When he was drawing that, he was drawing the whole box gutter, and this is just the flashing of the gutter itself. I think.
Yes. Yeah. So this little piece here, which the leader is heading to, that's just the flashing that goes over there.
Okay.
Yeah. The other, you're referring to the other gutter I drew where it had a sloping bit and then flat. Yeah, that's for a different scenario.
A different. Okay.
So with this one here, this is where we have a truss, and that truss is designed to have a strong enough bottom cord for that bottom cord to extend through to here. So it's a truss designed to accommodate a box gutter. So when you tell the truss manufacturer, this is what I want, they'll go, yep, we can do that, but we need to have a stronger bottom cord to be able to do that. But they can do that sort of truss like that. Or the other scenario is what I drew up here, is where you don't have a truss, where you've got a rafter that comes down like that, and then purlins here. So your rafter has to mount on something over here on the other side of your box gutter, so that has to be mounted on there. So the rafter has to continue.
Okay.
You can't just go to there and go, all right, we'll chop the rafter off and it can hang in space. So that's why you carry your box gutter up, and that's why you have a sloping portion to your box gutter, and then flat there. So this is a different scenario. So we just have a little flashing up here to help stop any splashing that happens. It's all guided back into there. And also our box gutter can get higher and higher and higher as it goes upstream, and that flashing can accommodate that as well.
Michael, is there a box gutter over there? Have you seen that?
Yeah, it probably is.
Is that the insulation you talk about? Yes, underneath.
No, you go this way to see it.
Oh,
Yeah.
it's not good.
Yeah, no, you can't because they've got plastic roof.
Oh,
Yes, yeah, there's insulation. Yeah, so we have insulation carried along under our roof sheeting here, and then also insulation has been carried
so
underneath
yeah.
the box gutter
Okay.
there. And then so that's a very large box gutter, isn't it?
Yeah.
It's a really long one.
Guessing it's about I know it's about 500 millimeters wide.
There's more than that.
More than 500.
Yes. It should be about 6
About
or 700.
600.
Yeah, 6 or 700.
600. Yeah.
I went to the roof.
Yeah.
Yeah, it's not this much.
Right.
Yeah.
Are they deep? Are they very deep or are they quite shallow?
Okay.
Shouldn't be that. See that size of that.
Okay. Wow.
Oh,
Yeah.
it's deep.
Yeah, that's yeah.
How about
That's
the
deep.
foot?
Yeah.
How much?
How about the
Oh,
foot?
yeah. It's not big.
That's deep.
Yeah, we can see that. See.
Yeah. So you'd want to have fairly large, well, fairly strong hangers to take that weight of water as well, because you end up having a decent weight of water there as well when you're 700 or so wide and 400 wide and deep.
I think you can go to the top of the roof
Yeah.
and see it.
Yeah. All right.
Yeah.
Just from a staircase or something.
Yeah.
Yeah. Right.
If you have a pass key.
Okay.
Yeah.
Yeah.
Because there is a one roof there for solar panel.
Oh, yeah.
Yeah.
Looking at the solar panels.
Yeah.
Oh, cool. Thank you.
It's a pretty large drain pipes as well.
Right.
Oh yes.
Size of.
Yeah. So this was
Oh yes. Yeah.
is
So,
around like
yeah. They're 250s, I think. So yeah. I think that's a 250. Yeah. I did some work at an industrial site that had just the so they had downpipes coming off this big factory and then it went underground and it all came out at one pipe. It was about this round. I should have taken a photograph of it because it's about as round as I am. Coming up out of the ground. Yeah, that's a very large downpipe. And that's an intermediate downpipe as well. That's not one at the end. So we've got these happening. Intermediate ones. So
I wonder.
Yeah, I can see one down
yeah,
there.
one there. Yeah, one there. There's one on the outside.
Wow.
I can't see the outside.
Oh yes, yeah. See another one there. Another
It's a
intermediate one, and then
continuation,
yeah. So box gutters must be supported by roofing materials that can span the appropriate spacing. Spacing is determined by the style of roof setup, timber trusses, box gutter straps, etc. So box gutter straps, typically these rules apply. Bracket is suitable for designed water depths up to 300 millimeters. Bracket spacing is 1 meter spacing maximum for gutter widths up to 800 or 800 millimeters. I shouldn't say centers. Reduce maximum bracket spacing to 800 millimeters for 900 millimeter widths and 575 millimeters for 1 meter widths, or reduce design water depth in proportion. So, what about our bracket spacing up there? What would we estimate that at? That looks like about 600 millimeter spacings. Was it less or 500?
Oh, more than that.
It's more than that.
More than that?
Yes. It should be up to
Yeah.
8 to 900.
Maybe that's 800.
8 to 900.
Close to that.
So it says here reduce maximum bracket spacing to 800 millimeters for 900 millimeter widths. So maybe could that be a 900 millimeter wide box gutter?
Yes.
Possibly,
Maybe
yeah.
from the under, it's not up to, but from the top, it might be. I suspect.
Yeah. So that's the box cutter here being installed. So we've got our pan, or our decking to support box cutter underneath. We have our hanging brackets. Those hanging brackets we can see there.
Which one is bottom? This one, do you see the bottom plate of that one there?
Yeah, this one here. Yeah.
Oh, okay.
Well, we can see it there as well.
Yeah, okay.
And these are the hangers that sits on.
It's just like a normal roofing sheet.
Yes. Yeah. Yeah. Well, it's what's it called? I can't remember what it's called, but it's the other term for it is Greco. So it's where rather than it's not corrugated like custom board like that.
Okay.
It's actually like this.
Oh, okay.
So yeah, it gives you better span and better support for the gut underneath. I have also seen marine ply used as the support, the base support for gutters as well. But how you go, the process of specifying that, I can't shed any light on. I don't know how that's specified. And I think that way of supporting a gutter is a better fashion as well, because if you get any leakage like through from the box gutter, that water can stay in those channels and go out. Whereas if it goes onto marine ply, then it will start. It's marine ply, so it's resistant to water, but you get water staying there and starting to rust out the box gutter, etc. Cool. So class exercise, using the link to the box gutter calculator, this link here, you're required to design a box gutter using box gutter and rain head at the end of the box gutter simplified. Note that the roof catchment area is the total of all horizontal roof areas drainage on all sides of the box gutter, including half the area of any vertical faces that may run off into the box gutter. So what we can do is we can come up with a fictitious building if we wish, or we can use a building from the assignment. And grab, copy this. It's not let me copy it.
Control
Control,
and
click on it and come.
Yeah. Oh, we actually already have it over here. We might as well run through a few scenarios. So downpipe and eaves gutter calculator. Let's do that. So it's really simple. So to calculate, enter roof area, roof slope, and rainfall intensity. Press the calculate button associated with that section. Note pressing the enter button will also dismiss the alert box. Here. Oh, put that box up there again. Causing issues. I'll keep it minimized like this so I can go back. So I can cross tabs if you don't mind.
When you have to enter the roof area, is that just looking from straight down, or do you have to calculate depending on which angle it is?
So For this calculator, it's planned area. So
Because it's a flat roof, or
no, because
It requires slope. It requires
yes,
slope.
yes. So you put your slope in there.
oh yes.
Yeah. So if you're using the Australian standard, that's very different. There are multipliers that you add into the equation. But this does it all for you. So it says it here, in brackets plan. So roof catchment plan area. So how big is our house? Let's say it's 180 square meters. Well, no, we've only got one section, one side of the roof going into there. So 90 square meters of roof. What's our pitch of roof? 25. That's a good pitch. 25 degrees. Rainfall. Either choose a location, so we can go Adelaide. Yep. Sure. All right. So 90 intensity millimeters per hour, so that's only 120. Tick if gutter slope is steeper than 1:500, i.e. 1:200. So 1:500 is the minimum slope you can use for an eaves gutter. Well, let's be conservative and not tick that box, but when we go to install it at steeper than that. So we calculate it at the absolute minimum. There we go. Well, so you require one of the following downpipe options. So our downpipes, 90mm diameter, so that's what we want. We don't want to go to 100 or 150. We want to keep it normal. So we need 2 downpipes for that run of gutter. Gutter depth, 65mm. Well, that's going to be easy. Typically you've got 115mm gutters or 110mm gutters. So that's, for our standard gutters we've got to buy off the shelf, or it might be 115 or 125 you buy. So that's fine. That'll do it easily.
With gutter width, it's 125. What was the minimum again? Wasn't it 300 or something?
No, this is for an eaves gutter.
Oh,
So
okay.
so we're just calculating for an eaves gutter. So that can be done easily. So we're using 2 90mm downpipes. We can use a standard gutter. That's fine. However, if for some bizarre reason we don't want to use 2 downpipes, we can cruise on down to here and we can use 150mm downpipe. We'll do the whole lot. We can use one. But 150mm downpipe, that's a downpipe like this. That's a big down. That's a big downpipe.
There is any maximum and minimum between downpipe?
No. So it's about that interplay between the size of gutter and the downpipe and the frequency of downpipes. So you just have to make sure that there are enough downpipes to carry the water away. That can be done either with, in this scenario, 2 90mm downpipes, which I think is the best scenario, or we can do it with just 1 150mm downpipe.
So would that affect or cause issue with the sloping, which will affect the aesthetic looks of the building?
Yeah. So
In fact, if you want to consider maybe looking the building aesthetically,
yeah.
running just one downpipe for the whole building.
Mm-hmm.
To make the pipe maybe make it look somehow like you're running the whole gutter downpipe like around the building just to get to that one.
Yeah, the gutter all the way around and you just go to one.
Yeah. Make it look somehow, so I don't know.
Yeah, well then, yes.
If they consider things like that. Like that one said 90, in the case of this, I said 90 diameter.
Yeah.
And just 2 downpipes.
Yeah.
So if, for instance, the building is gable roof, or maybe like a hip roof.
Yeah.
Then what would then happen with the 4 edges if you just have just 2 downpipe?
Yeah. So what we've done, yeah. So we calculated this essentially for a gabled roof, but it's simple enough.
I think it was for half roof.
What's that? Well, half roof. Yeah, and I guess that applies to a hip end roof as well. So let's say it's a hip roof. So this is our building here. We've got hip roof happening.
Yeah.
So what we did, we decided to go with half that. So it's 180 square meters.
Okay.
In total, we went for 90 square meters to going to this side like that. So we've calculated the gutter along here, gutter along there, gutter along there, and it's told us for that we need a 125 millimeter wide gutter that's 65 millimeters deep minimum, and we only need 2 downpipes. So what we would do is we have downpipe location here, downpipe location there. Let's say we had, this is our building underneath. We had eaves happening there. We had car parking here like that, and we had to have a scenario, where we have to carry that downpipe back to the corner like that on an angle, and for some reason we think, okay, that's going to impede people walking through there or something. That's a terrible idea. We could put a 170 millimeter wide gutter on there. It'd be expensive, and then go to just one 150 millimeter downpipe here to take that side for aesthetics or for practicality or something.
Is it too risky, no? If the leaves or branches.
Well, yes, it is. Certainly, it is added risk. That's for sure. Because with that scenario, you've got a downpipe at either end, and you have your high point here, and you have slope heading that way, slope heading that way. And that scenario is much better if you've got soil movement as well. Because if you've got uplift happening, yeah. So this is by far the most common scenario. You have 2 90 millimeter downpipes happening there. It is very rare that you would deviate from that scenario for many reasons. One, because it's certainly less risky. It's also much more practical because you're dealing with smaller sections of downpipe, 90 millimeters instead of 150 millimeters, which is expensive, and smaller bits of gutter. And and the aesthetic considerations are generally not too important there. Sometimes they are, and so you look for other scenarios. So that's calculating for eaves gutters. That's really quite simple. However, let's say somebody says, oh well, I want you to do this calculation not for Adelaide but for Normanville or Centre Valley or something, or Kangaroo Island or something. So, we only have Adelaide in our tick down box here. Are we going to have the same amount of rainfall happening on Kangaroo Island as we do in Adelaide? I wouldn't pay that chance. So what we need to do in that scenario is open up. So we go back into the Australian standard. Grab him out again. So this is the Australian standard 3500.3. So it covers the design of eaves gutters, box gutters, etc. And it refers to, so for rainfall intensity, well, to keep things simple and not comb through the standard, it's in table E, or section E of the standard, or appendix E of the standard. So we head down here to appendix E. Are we there? Which appendix is that? appendix jacket, yeah, so way up much higher than that. There we are. So, so appendix E. So we can head up to right up to the top of the map of Australia that shows us South Australia, or we can just chance upon the map of South Australia here. So let's say, yeah, so almost the majority or the vast majority Kangaroo Island is between that 180 and 170. So we're at 170 millimeters rainfall intensity for Kangaroo Island. So we can't. So a good thing we didn't just click on the box for Adelaide, because we have much higher rainfall intensity there. So determine that. I apologise for that box up there getting in the way. Where were we? Expand that again. Oh, here we are. This is our. That's the one I was in down earlier. So rather than go choose Adelaide, we'll go add. For some reason my keyboard stopped working. Yeah. For all intents and purposes, we just type in 170 there and do the calculations.
Number form or something.
What's that?
Probably a number form or try with other numbers.
Nothing's working.
It was working, just
Change
Yeah, it was working just a little while ago.
Change Adelaide to now.
Change the location.
Oh yes.
First time I preferred.
Oh, I prefer it. Thank you. Excellent. Thank you. Yes. Keyboard. That's an issue with the operator.
Can we turn the lights on?
No, that's
You
okay.
want the lights?
Can we,
No, it's all right. We'll be finished very soon.
Oh.
So, yeah, that's all right. And we'll keep that box unticked, and then go calculate there. So then that'll give us a slightly different answer. So now we need 3 down pipes if we're going with 90 millimeter down pipes. Yep. So you'll still need to refer to that Australian standard for your rainfall intensities.
so will it depend on what kind of roof you have, whether you're filling the whole roof or just half of it? Because you just entered half the roof.
Yes, so
area.
we just
Alright, so if you have that's what if you have a gable ended roof or something.
yeah, but still halving the roof works for hip end roof as well. But if we had, let's say, so what we're interested in is finding out how much water is going to flow to that gutter or that that length of gutter. But if we had another section of the house over here, we might go, all right, well, we're really on, we've calculated that bit, for example. What we're interested in is this bit here. So we'll calculate that to see how many gutters or how many downpipes. Or we might go, no, let's do the whole shebang, add the whole thing in there, and then space our downpipes accordingly. So we'll go, we need 8 downpipes. We have X many meters of gutter happening around there. This is the frequency of our downpipes. So you can decide how you want to calculate it. So more calculators. Box gutter to rain head. We'll just go box gutter rain head simplified. catchment area. So let's say that building, instead of being a hip roof, it was just sloping one way and it was sloping towards a party wall. So we are, what were we, 180 square metres of catchment area. What's our roof slope going to be? 25? 20, what's that?
26.
26. Do I have any improvements on 26?
Yes, it's 20. 20.
Yeah, 22.5. Let's go with 22.5. It's half of 45 degrees. Right. And we built it up in Darwin, let's say. So, yeah, 380 millimetres. So we're getting a fairly intense scenario, aren't we? But it's got a slope 1 in. Well, let's make that slope 1 in 80 because we've got very intense rainfall. We've got a roof slope of 22.5 degrees heading towards that box cutter and a fairly large catchment area. What size box cutter should we try for that?
The minimum was 300.
Yeah. Well, minimum for residential is 200.
200.
But I'm just going to say 450. 450 wide box cutter. So that's a trial. Flow is greater than the code allowed for 16 litres per second. All right, let's build the house somewhere apart from Darwin. Brisbane. Ooh. All right, let's build in Adelaide. So it's done it. Yeah, so we can build such a scenario in Adelaide. We can't build that.
Everything is better than Adelaide.
What's that?
Everything is better in Adelaide.
Oh, it's easier. We don't have to do tie downs for cyclones. We don't. Yeah. So minimum. So that's going with a 450 wide box gutter. Trialing that. Roof runoff litres per second. We're still getting up there, aren't we? 11.47 litres per second. So we wouldn't have wanted to build this anywhere other than Adelaide, I think. Suggested downpipe diameter 131. Well, don't get downpipes in that diameter, but we can go to a 150. Minimum gutter depth with no slopes 146. This is what we're concerned with, although that's a good figure because that tells us how much depth we actually need. So we can have 146 millimetres in there and then use our 117 millimetres and take up that 30 millimetres in slope. So minimum gutter depth, 117 millimetres. That's very doable. That's very easy. So maybe knock that back a bit. Okay. Let's think about a very standard size box gutter. Very cheap. At depth, 135. That's pretty doable in many scenarios. And so we're going to have to accommodate about 180 millimetres depth for that box gutter, plus our hangers and support, etc. So we're probably looking more at accommodating 250 millimetres depth there. Suggested downpipe size, 131. Well, we can't really do that, so we have to go for 150. Put in 150, and then that tells us our size brain head. So depth of brain head, 188 millimetres, length 176, width 300. That's also a very doable brain head. We go to buy a brain head, it's going to be much larger than that anyhow. There you go. It's as simple as that. Oh, one thing I think should be explained though. So you remember earlier on, we chose Adelaide, and it gave us a rainfall intensity of 120. Then we did the box gutter, and it gave us a rainfall intensity of 190. the reason for that, and that's buried earlier on in the Australian standard, and it says that for eaves gutters, you have to use a rainfall intensity of 1 in, what's going to happen 1 in 20 years. So the worst rainfall event you could expect in 20 years. For a box gutter, you have to cater for the worst rainfall event in 100 years. And so that figure, that rainfall intensity figure, differs between box gutter or eaves gutter. And so in table E, that gives it for box gutters. But that's it for tonight, unless anybody has any further queries about that. So I'll see how we go. I don't think there's any necessity to have a class next week. So I will let you know via email if but we have several classes. We'll have several weeks still until the 27th. It's the 7th today, isn't it? So essentially we have 3 weeks. 3 weeks in which to cover all asylum questions and so on. I think it's probably a good idea to get together another week sometime to have a workshop session or help sort out issues with assignments if that's needed. But I think next week is probably not the best time for that. But in terms of covering everything, we've covered everything. Well, what we haven't covered is internal linings for the 3-story commercial, but that doesn't really differ from the internal linings from what we've covered previously. So there's mention of it in Moodle, but I don't think it's necessary for us to rehash over that.